Hi. How's things? End of the day? Everybody sleepy? To get like the afternoon coffee or whatever? Let's do the wave. Okay, so let's start over here. And then we're going to go woo. That didn't work super well. Come on, let's try again. Ready? Woo. And then we're going to go back this way. Ah. And then we're going to go this way. Ooh. Okay, that was good. Boop. Okay. Well, if you're in the back, you could come to the front if you want. You don't have to, but it'll be easier. It's not a very big room, and Jennifer told me I have as long as I want, which isn't true. I swear I won't take like an hour and a half, which I've done before, but I won't. But if you have questions, you could interrupt me, and then if it turns out that that's just dragging us on and on forever because you're just like a question-y crowd, then I'll just stop taking questions and ignore you, which would work. So I want to give a talk that's about the evolution of automation. And this was a hard one. So I spent the last year building a thing, and that thing is called Habitat. How many people have heard about Habitat in the last thing? That's pretty good. So I built this thing, and it's called Habitat. And my background is I'm a systems administrator, and I wrote a thing called Chef. And then Chef got to a big enough size where I had humans who were awesome at running things like engineering and product. And so I could go off and do R&D, which was great. So should you ever get a chance to do that, you totally should. And I was in Mexico on a month vacation, which is also a thing you can do when you have people who can run your company for you, which is also awesome. So vote yes for that. And I started thinking about what was wrong with the way we build and deploy and manage our infrastructure, and the way we think about building our environments. And in particular, I've spent a lot of time with customers and people out in the world, in large enterprises and small startups and all those things. And the truth is, it was sort of brutal for everybody. And the one thing that's true is that all of us want to get to a place we're at DevOpsDays, and our goal is really to get to a place where we work together to build great products and to further our goals, our companies, for whatever it is that we do, right? And if we're going to be good at that, there's really an order of things. So the first thing we have to be good at is in creating an environment where the people who do the work are happy. So one of my things that I believe is that sad people build sad products, and sad products build sad companies. It sort of goes in that order. There's never, ever been a team that was miserable who built a product you love. They just weren't. Like, it doesn't happen. So it starts with getting to a place where the people who do the work are stoked. Those people have a shot at building a good product. Those people have a shot at then becoming a good company. No guarantees at any level, but it doesn't hurt. So if we think about those people, like, what do we do to get those people in a place where they feel good and they're happy and they understand sort of what will help them create good products? And there's sort of this virtuous cycle that happens here where it starts with our culture, so the way we act toward each other, right? So, and a lot of DevOps is about culture, and I'm sure we've talked a bunch about it today, right? And then the other half of it is the technology we use to just go through our day-to-day lives, right? The things we do all day to just do our work. And those two things form this sort of reinforcing circle where if we decide that we want to do DevOps. How many people, this is our first DevOps days? And you want to go home and do DevOps? Hopefully that number was like 100%, but it was like, for those following along at home, it was like 75 tops. So there's a few people not convinced. And so that's awesome. You're like, sweet, I want to do DevOps. But then you're going to go to work on Monday, and all the technology for all the things that you've ever built follow Conway's law, which is that your technology follows the organizational structure. And you're like, I want to do DevOps. And they're like, no, because you can't. And you're like, why can't I? And they're like, source control belongs to the source control team, or whatever, and then you're miserable. A great example here is workflow. Like, you want to get your product to your customers faster so your customers can be happy. What's the workflow that we go from a developer making a change going all the way through to production? Can everyone even see it? In a lot of places, the answer is no. And if we sort of break down how to fix that technology barrier, if we've sort of cracked the nut a little at least on what we want to be culturally, and I think we kind of have. Like, I don't hear a lot of people arguing for the silo, right, or saying it's better to not collaborate or that we should be miserable. But on the technology end, it's easy to get lost in sort of the technology for its own sake. Like, it's fun to build automation, and it's fun to build platforms, and it's fun to do the thing. But what are we doing and why? What's the thing we're doing to help each other get better at building applications, deploying those applications throughout their lifecycle, and managing them while they're there? Because that's the actual work we do, right? Whether you're an application developer, whether you're a systems administrator, whether you're a security guy, whatever you do, that's your loop. That's the thing you're trying to fix. So if you're in the enterprise and you walk away from this and you think, Adam was smart, we should fix the build, deploy, management loop, right? Your world, to begin with, looks something like this. So you've got some infrastructure here at the bottom that's like physical gear from a bunch of different vendors. You have some virtualization. You've got some cloud providers, maybe more than one. You've got multiple operating systems. And then you're starting to have these like runtime layers on top that are like, we got some Mesosphere and grid stuff happening. We've got some like Cloud Foundry paths going on. We've got some containers and discovery systems. And all of that stuff is cross-cut with all these silos in the organization. There's like the product team, and there's the systems guys, and there's the application developers, and QA, and operations people, right? And theoretically, there's sort of this left to right marching line that's going to get you through both all that infrastructure and all those silos to sort of poop out the other side running product, right? But that line it's not a straight line, in case anybody is like anxious about the answer. Like, what happens here is you just bounce around back and forth like a crazy person, right? Both through the layers and through the silos. And so you just sort of squiggle your way to production. And when you sit down and you take that as your example, and you go, great, how do I build software that helps that build, deploy, management loop? And you're thinking about how to design a solution to your problem, right? That's your situation. You're in that environment. What do you do? And really, two things confront you. So the first thing you do is you design for your silo. So if you work in operations, you will build operational software to optimize the build, deploy, and manage lifecycle, because you don't control the application. And if you try, they will come find you and punch you. They'll be like, no, right? And then you're like, oh, boo. And so then you go back to your like operations land, and you're like, okay, I'm gonna build infrastructure. Let me Kubernetes, right? And the applicators will be like, I like the sound of Kubernetes. My application, is that an application thing? And they're like, no, infrastructure. Absolutely infrastructure. And they're like, great. And so it feels good, man. You design for your silo. And as long as you stick sort of inside your little bubble, everything's cool. But the problem is, what you're solving for is this very big loop, that build, deploy, manage loop that goes all the way from the left all the way to the right. But you're not really allowed to solve that problem. And so then one day, you become like Rob. And what happens is you become like the boss, right? You're like, I'm the VP of good times at my like giant enterprise, right? And when that happens, you get to pop up and design the grand unified field theory of how your thing is going to work, right? And what you are then forced to do is integrate your unified field theory with every choice, every silo made, right? So this is how you wind up with like Jenkins that like runs jobs across all the things and like a pipeline, and it touches like 50 different things, and it like runs Qualys, and like it does all this madness. That's what happens, and it's because you were forced to integrate into every silo's choices, because you're still essentially siloed even if you pop up high enough. And what happens with products that are forced to integrate is that they tend to become soup, right? Your solution is complicated and it's hard to understand, and it's not very gratifying, right? Has anybody ever built one of those? I totally have. Yeah. There's a little bit of sheepishness. So there were a couple arms that started to go up, and then they were like, my neighbor didn't build one. Your neighbor built one. Okay. So then you're like, man, this enterprise thing is a drag, right? I don't want to be. I'm not gonna. Let's not even do this enterprise shtick anymore. Instead, let's look at the web, the big web. Let's look at Facebook and Google and LinkedIn and Netflix, and like those guys got it dialed up, right? And they do. They are way better than most of us at building, deploying, and managing our software. And when we look at them, they kind of look like this. They have an infrastructure platform that's relatively common, right? That like everything sort of just uses the same infrastructure. You know, everybody knows about like Facebook and Google with the off-the-shelf boxes they build themselves and their commodity hardware and all that, right? Which is very not the enterprise, right? And then they built a runtime layer on top of it, right? And they were like, hey, this runtime layer is pretty cool. And let's put operations people who run the runtime, so they run the interface between the application and the infrastructure, and they do both, right? So there's operations that do that. And then there's software developers who write new code that sort of runs through the pipeline, right? And it goes super fast, and you're stoked. And so if you are in the big web, and you are looking at this giant problem of how do we build, deploy, and manage all the software in the world, you tend to go, let's just do that over there. Like, let's just go from what we do at Facebook, and let's do it at GE, or let's do it at Allstate, or let's do it wherever, right? Which, okay. But when you design from this perspective, a couple other problems happen to you. So one is that those guys all had control over the application from the day it started. Netflix is Netflix because they wrote Netflix. They didn't go buy Netflix. They didn't like go to someone else. They didn't go to SAP and be like, do you have a streaming movie module? Right? Like, that's not how it rolled. Like, they just wrote Netflix. Facebook was Facebook because Mark Zuckerberg wanted Facebook. And so he wrote Facebook. And then he was like, we should build a platform with the Facebook. And what's cool is $1 billion, right? And when you map that over to the enterprise, you don't have any of that, right? Like if you run a bank, you bought the software most likely that runs the bank. You didn't write the bank, right? And banking is 300 years old. What are the odds you would mess it up if you did? Like, I don't even know. It gets weird. So they had control and you don't. And so it doesn't really map one-to-one because those choices were part and parcel of the entire life cycle of those companies. And then the second thing about those companies is that the platform they built, that capability to have that infrastructure and that runtime to be Facebook or to be Netflix or to be Google, that is the product that they sell. What is Google but the platform that runs Google? Like, if you took it away, there wouldn't be a Google. It literally just wouldn't make any sense. It's nonsensical to say it out loud. But if I took away the infrastructure of online banking over the entire world tomorrow, you would still have a bank. Like, people know how to build a bank, and they can just do it. The platform isn't the bank, right? The bank is a thing. It exists in the world, not in your brain. And so those two things imply, it's not a priori valuable to build the platform in the way that it was to Netflix and Google and those dudes. And so making those same choices that they had to make to get those platforms to work, we'll do it if we had to, but it's weird that we think we have to because they don't actually fit. And then if you remember, we're now a little bit into the story, so you might have forgotten, I was in Mexico when I was thinking about all of this, right? And I was on vacation, and I was like smoking a cigar. And the next problem I had was, okay, well, the other problem is that I run Chef, and so people hire us, and I like to go in the field and do work, so it reminds me what actual customers go through, right? And I had seen all these people try to automate their infrastructure, and it's all good early, and it sucks a lot the closer you get to production. And so an example here, I'll use Chef, but we can map this to anything, Docker, doesn't matter what the software is. It starts out awesome. I'm actually going to use Docker because Docker's getting started experience is so much better than Chef's. Everybody raise your hand if the moment you ran Docker run IT some piece of software and hit enter, you were forever going to use Docker forever. Okay, if you didn't raise your hand, it's because you've never run the command or you're a fool. It's so good. It felt so good. And so that's the beginning of this thing. You're like, yes! And it feels awesome. And so then you're like, I'm going to use Docker. And so you're building Docker images, and you're putting stuff out, and it feels awesome. And it gets a little harder. You're like, man, networking's a little hard, but it's fine. I got it, right? And you're putting stuff in, and it's cool, and you're building stuff up, and you're like, yeah, man, I'm doing QA. It's feeling good. I've got some Docker. Look at the images. They're immutable. And what happens then is you're here. And so I call this the peak of false hope. And And the peak of false hope is the moment where you think you've got it all figured out, and you know all the things that are going to bite you as you get closer to production, and you're ready, and you're like, let's do it. Let's go to production. Let's put it all together, man. I got this. And then it works. It's glorious. You start putting it in production, and it's like, yeah, and it all sings, and it's really good. And that's this little down ramp from the peak of false hope, right? Because it gets a little easier. And that's right before it hits you in the face with a board full of nails. And it just keeps doing it to you. It will do it. It's going to hit you in the face with nails forever. But you went through this emotional journey with that. So like, as a person, you're actually a little into it because you triumph over the difficulty. Do you see what I'm saying? Like, you love it because it's hard, and you kicked it in the junk. You were like, yes, Docker, production, I'm the man. Or like Noah Kantrowitz, who I love. Noah has done this with Chef so mightily, right? That he's sort of come down the other side of the peak, and he loved it at one point, and now he just sort of hangs out every once in a while being like, dude, you hit me in the face again. Seriously? You're still hitting me, right? Okay, so the other problem was that moment, though, with Docker in the beginning of that story, that was right. Like, that was a true moment, and it felt right. And if you think about your cell phone, as I was sitting here, like, smoking this cigar, and I had my cell phone, I was like, my cell phone's like that, too. Like, they used to be really difficult to use, and, like, my Palm Trio, and, like, you compare it to my iPhone, and it's not even the same. And they sort of solved that cliff. Like, now I do a bunch of things that I never could have done on the other devices, and it didn't get harder, right? The device got way more complex, right? But it actually didn't get any more difficult as they added in more and more power to the thing. Like, it actually got easier, or at least stayed flat. And I started asking myself, why can't that be true for all of us? Like, why can't that Docker run IT blah moment? Why can't that just be the moment? Like, why can't it just feel like that forever? And can we stop? And so I noodled about it, you know? And I thought, okay, what would it be like to build, deploy, and manage my environment and to never have it hit me in the face with a 2x4? And unshockingly, maybe for everybody, I came up with Habitat. I'm trying not to make this a product pitch, but like, now I kind of have to, because it's hard for me to describe to you what the thing is that I figured out without talking about the thing that I figured it out with. So the thing I figured out was this thing we call Habitat. And the first thing here was that we needed application automation. And the way you realize this, if you look at the way we've been building infrastructure and thinking about automation, is that slide where I showed the enterprise, and there's that big infrastructure box, and there's the big runtime box. So the box on top of that, in the diagram I normally use, just says applications, and it's a big black box. It's just a big box, and it says applications, and there's nothing in it. And I was sitting there being like, hey, it's weird that there's nothing in that box. Like, if that's what we wanted, if what we wanted was our applications to be easy to manage and to automate, why is the box empty? Like, shouldn't it be about the application instead of being about the infrastructure? And so I went and I started building prototypes, because that's sort of what you do, or this is what I do. And I started playing with Docker, and I started playing with everything I could get my hands on. And what we came up with was this idea that if you wanted to really smooth out that curve, what you have to do is make the automation travel with the application itself. So the one activity we know we're always going to do is we're always going to build an artifact. Like, I'm going to build something that I deploy later, right? I'm going to build a tarball, or I'm going to build a package, or I'm going to build whatever. And if the automation traveled with the application, then the second rule would be that it would have to behave the same way everywhere it got deployed, right? So the application would have to work the same way everywhere, all the time. And if it did that, then it probably also would have to have no other requirements. So all the automation for its whole life cycle, across everything, has to work in the application all the time. And if we did, it would be autonomous, right? So you'd be able to deploy the application, and the application would sort of take care of making itself behave correctly. It would be idempotent, which means if two of us ran the same application with the same options, it would give us the same behavior, right? It would be convergent, which means that if it couldn't get to that behavior, it would just keep trying in the hopes that the reason it couldn't get there was that the environment around it was wrong and that eventually it'll get fixed. It would be declarative because I don't want to have to tell everything, all the steps to get through its whole process all the time. It would be a little abstract, right? So I'd be able to think about the abstraction as opposed to all the details about everything that's inside of it. And in the end, the artifact itself would be immutable. I need to be able to know for sure that if I'm running the same artifact as you, that we were running the exact same code with the exact same dependencies sort of through its whole life. And it might not surprise you that this list I pulled, except for immutable, I pulled from an article we wrote in like the Web Operations book in like 2008 or something, right? Like it's the same stuff that we've been talking about at DevOpsDays since the beginning. But it moves around where those behaviors live, right? So thinking about these as properties, these are important properties to building systems that are easy to reason about. It doesn't matter what layer you're building them at. If you want a system that's easy to reason about at any layer, it needs to reflect these behaviors. So, how many people know Mark Burgess? Mark Burgess is the man. He wrote CF Engine. He also wrote a bunch of papers. He did all the science. So if you think all the things I'm talking about are cool, it was Mark that did the science. I'm just like a Pied Piper implementer for Mark's theory. And promise theory is sort of the other thing you need. So if you think about these autonomous actors, they need to then interact with each other and with their world around them. So to put it in technical terms, I need to be able to do service discovery, right, of other service. I need to be able to say, if I'm a service and I require the two of you, then I can know who you are and I can find you somehow. I need to also be able to do like topologies and dynamic stuff within my own service group, so I need to be able to assemble myself. And promise theory tells you that the only way we can do that is by having each supervisor have the behavior about what it will do when it sees its local environment changing. Does that make sense? So what you can't have is an external actor that goes and pokes everybody and says, this is where it is, and go over here and orchestrate this, right? Instead, you have to have each of you individually smart enough to behave in a particular way. And you promise to other people that you'll behave that way given the right set of inputs, right? So if I ask you to do something and you say yes, I expect you to do what you said. And if you don't, then I'll stop believing you, right? Broken promises, right? And that is also sort of built into thinking about Habitat and how we're going to move up. So if we want to be better at automation in general, forget about Habitat for a second, every layer of the stack that we use has to learn how to do this set of behaviors. They all have to do it because it's what makes it easy. It's how we get away from that crazy curve that hits you in the face, right? Okay. I already hit on this, but essentially there'd be a bunch of other stuff that you have to be able to do at the application level that historically we think of as infrastructure. So an example there is what's the right configuration for the application? How do I choreograph updates? How do I talk about a topology? How do I do service discovery? How do I manage secrets, OpenSSL certificate, or SSL certificates, or all kinds of other things? That stuff has to happen from only deploying the applications themselves. You can't do it by deploying other services. If you do, then the curve comes back. And it has to work both for existing software and for new software. So it has to be easier to build new software using Habitat or whatever the thing is we use without having to sacrifice all the software we've ever built in the world, which for the record is the software that runs the world. So we talk about it as legacy software. We're like, that's the awful software no one wants to work on. And it's like, yep, but it makes $20 billion in revenue, right? Like, it runs the global economy, but we could rewrite it with Spring Boot, right? We could. I'm sure we could. Okay. All right, so I'm going to talk a little more about Habitat itself. So for us thinking about this problem, we started with the second thing you have to be able to, another thing you need to be able to do is think about, if it feels like I'm wandering a little, it's because I'm trying to be as nerdy as possible without putting all the nerdy things on slides. So forgive me a snudge. The other thing you got to be able to do is think about the stack differently. So one place that siloing brings you from that enterprise version is not being willing to think about all the layers that are involved in your problem, right? So if our problem is application deployment, we have to be free to think at all the layers that influence application deployment. This is a good example. So the packaging format we start with the very lowest level, how you describe how to build the software. And we package it together into an artifact, which we then store in a depot. And then we can post-process that stuff into multiple outputs, like containers and all kinds of other things. So in a little more detail, you start by describing this plan. And one thing about the plan files that I really like are that they're low abstraction. And they have a complete list of their own dependencies. So how many people have ever been bitten by trying to build a new version of your software and you had a dependency that moved on you? How many have been bitten by a dependency you didn't know you have? Same people. Okay, so this makes it essentially impossible to do, right? Like that as a problem is now no longer an option because the build system will just break. Like you have to be explicit about all your dependencies. You can declare how to run a service. In this case, this is Redis, so this is how you start it. And then you use simple functions to sort of override behavior. On the future of automation evolution point, one thing to understand here is that this is a pretty low barrier of abstraction. This is just a shell script and nothing else. And I'm the chef guy, so I love nothing more than writing me a good DSL. But the truth was, it didn't make sense. The instructions people tell you to use are just shell commands, and so that's what we should run. So thinking about abstraction, if we want to get better at automation, we have to think more clearly about when it's appropriate to introduce layers of abstraction. You also have to describe what's configurable about the artifact, because everything has to travel with it. This is the configuration options, right? The format we're using here is just TOML. It's easy. Humans can write it. It supports complex data structures. What's important here is that your data format, if you're building any kind of new automation, Habitat or anything else, needs to be human-centric. This was the lesson of Ansible. So Ansible is got a super easy getting started curve as well. And one of the reasons was that that description format of that initial Ansible thing was just easier to write as a human. You were like, I put in some pound symbols, and there was a comment, and all of the arrows and indentation. That has to then get translated to the configuration syntax of whatever it is you're automating. And so in this case, this is just a simple template, right? Again, it's very minimal. It does substitution, branching and looping, but there's no variables. You can't write a function. You can't do any of that stuff. There's lifecycle hooks. This is how you deal with other things like I want to initialize the software, what happens first, runtime things. These are also very simple. They're just scripts. You just run them. There's no DSL, there's no magic. If you want to put a C program in here, do it. If you want to run Chef, go ahead. You want to run Bash, do it. Who cares? But all the behavior that happens through the lifecycle is customized here. And if you think about this in terms of evolving the way we think about building our automation systems, the evolution here is simply that it's better to have less requirements about how you specify behavior. And they get built in a thing we call a studio. So a studio is a clean room environment. It's like a cheroot jail on steroids. And it's safe by default, and it installs all your dependencies. So when you build the software, you build it in an environment that only has the specific software that you specified earlier in the plan. And they get uploaded to a depot, which is like a package repository. This is another sort of thing you can think about when you think about building and evolving how we think about automation. There's always has to be a place for the artifacts to live. That's just true. The thing you have to think about is, if we're going to store those artifacts, can we build one that's public? How does it then work when it's private? How do we think about being able to cut specific views over what you want to see in and out of that depository? And we'll come back to how that stuff works in a minute. They're all installed. If I want to run those packages, I use a thing called hab, and that's just a command line client. And it's a pretty simple pattern. You say hab something, some noun. So in this case, hab install core Redis. If you've used Docker, this should feel familiar because it's pretty familiar. And you can increase the specificity of sort of what packages you want to install. When you think about this from evolving how you design your own automation, building a command line user experience, this is the first product I've ever built where I had a UX engineer who worked on the CLI. And thinking through what the expressions are that you want people to say is super valuable. So they get written out to disk when we install these packages. They get written out to a directory called hab packages. So one thing that we do here is, in order to, later on, you want to update your application. How many people have ever had a yum update fail in the middle? Like most of the room. How many of you knew what the state of your server was when that happened? None of you, because you couldn't have. So good job not raising your hand. Trick question. So one problem with that when you think about updating your software is that it's not atomic. So stuff happens, it lays down over the top. You also can't tell whether or not the software that you're running actually restarted to get the new version of the shared library that you updated, for example, up in like SSL. So Habitat solves that with the build system by basically doing dynamic linking at the layer of a release. So if you look at that LDD at the top, which is particularly nerdy, none of those shared libraries are linked to normal system paths. They're all linked to dependencies inside of Habitat. And the side effect of that is that you can deploy them side by side without having to worry about those dependencies. You could update to a new version of glibc on the same box with 2 different services, and it would just work. Whether you should or not is a totally different question. But the property of being able to is important. Because we have all those dependencies, we can post-process them into other packaging formats. So a good example here is Docker. If you want to build a Docker container out of a Habitat package, you just type hab package export docker core Redis, and that's pretty cool. Okay, so the next layer up in that build, deploy, manage lifecycles, that's the build part of build, deploy, manage. So now you got to deploy the thing and get it to run. So this is where you start with the depot. So you've got this package, you uploaded it somewhere, and now you want to run it. And so you start what we call a supervisor. And the supervisors run services. These guys are the supervisors. Do you get it? They've all got visors. Anyway. So the supervisor knows how to automatically install those packages we built. It knows how to keep them running, manage their configuration. And when you think about the sort of meaning behind the supervisor, what's interesting about this was we moved the configuration management loop. So if you think about the loop that you get with like Chef or Puppet or whatever, that loop happens on some interval and it configures things. The supervisor moves that loop to be tight around the application itself and reactive immediately. So rather than having a long-lived loop on a bunch of things, you have a very small, tight loop around a single thing. So we can configure that thing through a bunch of different ways. So the next thing you need to be able to do is, for example, ask what the value is. So an example is Redis, out of the box, fails to set the TCP backlog to the right value almost every time and then tells you so. It tells you the right value. So if you want to set it, one common experience you have is some piece of software has an error and you want to fix it. And so the first thing you ask is, where's the documentation for that thing? So you pop up the web browser, right? And you go to Google for Reddit, and then Redis, and then you find the configuration for Redis, and then you read the thing, and then you try to map it to the abstraction, and that whole loop kind of sucks a little if you have to do it a lot. So Habitat, remember earlier, we baked the configuration into the plan. So one thing we can ask Habitat is, what's configurable about this package? So you can just say, hab supervisor, what's configurable about Redis? It will print out a bunch of options. One of them is TCP backlog. So then there's lots of ways to set it. One would be the environment, so 12-factor style. Habitat doesn't make your stuff 12-factor, but it can make it like 8-factor or something. What's important about this is when you think about how to get behavior into the things that you automate, if you can take from other people's patterns that work, you should, right? So I don't know that I think it's a great idea to use the environment to inject all your configuration, but there's a bunch of people who love it. Like, that is their jam. And so it's in Habitat. You could use files. One thing we did to remove difficulty was, how many of you have ever asked the question, where's the config file for that? Yeah. So in Habitat, that config file is in hab service name of the thing user.toml. There you go. That's where the config file is for everything till the end of the universe. That's in Habitat anyway. So that's cool. Files are more flexible than the environment. They're a little easier to set. They have a universal location. And this, again, was a user experience thing, right? It was just, man, it sucks to have to go figure out where the config file is. So how can we make that not a problem anymore? We could make all the config files live in the same spot and have the same syntax, right? Okay, so then that's cool, but it's static. And so the next thing you have to do is think about how these applications we want to run form themselves up into more complicated shapes. So in Habitat, we did this by having a supervisor that forms a ring. So the supervisors communicate to each other, we call those peers, and they form service groups. So if you start, say, Redis, then what will happen is Redis will actually become a service group, redis.default. And they use a gossip protocol to communicate about each other's conditions. And this is where promise theory sort of comes back into the loop, right? So the supervisor is using gossip to share its state. So it's basically sharing its view of itself with everybody else. And then everybody else is sharing their view of themselves with everybody else too. And so over time, we build up a view of what the world looks like, and we use that to appropriately configure ourselves. So one thing we can do with that is we can use the ring itself to configure our services. So even though we could put it in a file, a better way to do it would be to just let the ring handle it for you, right? So you can pass a configuration to the ring, and then the ring, anytime a service comes up and says that it's in that service group, will automatically be configured correctly, right? And there's nothing to deploy. So you didn't have to deploy console or etcd or anything else. Okay, the supervisors also support topologies. So they do dynamic configuration. So this is at the group level. So this is like, I want to have a leader follower. So I want a Postgres cluster where there's one write master and multiple followers, right? And we use the ring to handle that same thing. One good thing to understand is that making that work is just adding command line options to the supervisor. So when we say we want to start the service, all we do to do that is say topology leader. And then the supervisors figure out what to do. Because otherwise, again, the difficulty layer would start to shoot up. This is an interesting evolution of automation thing that we discovered. It's better to have the data that we pass to the application be the API than to provide an API you have to write to. So what I mean by this is there's all this stuff we know about what's happening in the world and about the supervisors. We write that data out to a simple format, and then either you use a template to map that into your own configuration language, or use a hook to run commands to put it into your application, or you just use the data directly. So in this case, if we were doing that leader-follower topology, and I'll show you this at the end, it took 5 lines of code to make Redis do leader-follower election. And that's because the data is the API, and we didn't have to change Redis at all. So the next kind of thing you have to do is service discovery. So this is about between services. So if topologies are inside one service, service discovery is binding together 2 different services who need to know about each other. My Rails app needs to know about Postgres, right? And we do that by binding the service group one to the other and just giving it a key. So the question you're asking yourself is, what's my database? You would bind the key database to the value of the Redis or the Postgres service group that's right for your service. The principle I think you can think of here in automation land is that anytime you can add more, anytime going from left to right in the production cycle can get boiled all the way down to just another flag, that's pretty good, right? And that's really where you want to head when you think about how your own systems work. How can you make that experience of, as you layer in more difficult or more complicated scenarios, can you make that a process of progressive discovery and progressive reveal, right? You don't have to eat all the things in the beginning, but as you go, you can just layer in more and more things as you learn. The supervisors also can do update strategies. They're aware of their topology. So an example here is when a new version of the software is released to the depot, we can automatically update ourselves. We can track those views. You can do continuous delivery quite well with this. But it's another example of how the state of those things can make for really smart decisions. So they can decide, for example, that if all 5 of you are in a service group, that the first 1 of you deploys, and then 2 of you would deploy if he was successful, and then the last 2 would deploy, and that would be the deployment strategy. And if anyone failed, then the others would stop, right? Maybe roll back. I don't know. Still working it out. But they can also provide a REST API. So one of the things you have to do when you talk to applications is talk to them from services that aren't inside the ring, right? So load balancers are a great example. There's a hook for health and status. They're good for debugging the supervisor itself. Lots of external integration. Oh no, what do you mean didn't work? Do you guys want a demo? Or do you want me to stop? You want to see it? Okay, hang on. What's happening? I give it a second. Oh no, it got a little smaller than I thought it would. Get bigger. There we go. Okay. You guys see Willem Dafoe there? While this is working, you want to hear a joke? Okay, I need a helper. Who wants to help? Jessica, come hold this microphone. Is that too weird? Otherwise, I can't type. I didn't think that through. Can I use the podium mic? What's up, podium mic? Now it's less weird. Okay, thank you. No, that one can turn off. Okay, so let's do the leader-follower topology, right? So what we're going to do is we're just going to fire up 3 instances of Redis, and we'll do a little bit of like magic configuration sauce while we're at it. So let's start. We'll start Redis first. So it's going to go out. It's going to download Redis, and then fire it up. And what you're going to see here is that like TCP backlog warning. Do you guys see that? That's that 128 I was talking about earlier. So let's actually leave it running here. Oh, I didn't bring my awesome mouse. One problem with my cool terminal windows is cutting and pasting. The acceleration's brutal. Okay, so we're going to pull that guy up. We're going to pop over here to this other box. This is another completely separate VM. And we're just going to configure that Redis instance to fix the bug. So we'll say redis.toml. All right, so we'll do hab config apply Redis default. Okay, so what we're going to do is take that config file we wrote, and we're going to inject it to the ring. And if you watch what happened on the other side, we took that configuration, we applied it to Redis, and then we restarted the service, right? What's neat about that trick is now it's forever in the gossip ring. So let's start another instance. So we'll say hab start core Redis, and we'll specify a peer. So now I have 2 supervisors. They're going to form a ring. So, boop. So when this one came up, you'll note that it didn't have the backlog bug, and the log level was set correctly. But I didn't deploy any infrastructure, right? All I did was deploy the application, and the automation traveled with it. And the supervisors were responsible for going, oh, we actually have a configuration for Redis already. Here's the right one. Go ahead and use it. And if we spawn 10,000 more, they also would get the right configuration. So we can also layer in some more complicated stuff. Like we could say hab start core Redis topology leader. So the first thing it's going to do is just stop and wait, because there's no difference between being alone and being net split, right? So we want to start another one, so we'll do hab start core Redis topology leader. So now there's 2. So now they have a quorum, they ran a leader election, and there we go. This one was the leader, right? So the other 2 automatically configure themselves to be followers. This one's the leader. Let's shoot the leader in the head. So now the leader's dead. So the remaining 2 will have quorum, and they're going to go ahead and run an election, and eventually one of them will become the new leader. So one of the things we've lost in our brave new world is the ability to do sub-second failover. Does anybody remember the HA stack on Linux from the 90s and crossover cables? I met that dude in Salt Lake City who wrote that stack. He's amazing. Like, he's just this old guy, and he was there at like a DevOpsDays, and I didn't know who he was. And then he was like, I built some software you might have used. And I was like, really? What? And he was like, do you remember HA? I was like, you're kidding. He's like, yeah, I wrote the HA stack, and then I wrote Pacemaker. And I was like, and then we hugged, and it was weird. Okay, so there it goes. So now it did fail over, right? So now the other one's the leader and the other's follower. If we start a new one, it'll automatically become a follower. We could keep going, because Habitat can do a bunch of stuff. And what's funny is that there's not a lot happening on the screen in the demo, but there's a ton happening. Just think about how much infrastructure you would have had to deploy and how much services you would have had to build in order to get that stuff to work, right? And in this case, the only thing you had to do was build the Redis package. And that plan was pretty straightforward. It looked like that. So it's somewhere in the neighborhood of like 15 lines of shell. And then default.toml, These are all the things that you can configure about Redis, sort of translated. And then the configuration for Redis itself, which should look familiar to anybody who's actually used Redis. And you got this little bit of mustache where we're putting in the template variables for what's happening. But that leader follower trick, oh no, come on now. Every time I hit escape. Looks like that. So that's how much work we had to do to get leader follower to work in Habitat. So doing it is just super easy. So Habitat's application automation, it travels with the app. It works both for existing and cloud native stuff. The important part is that management has to live with the application layer. So rather than relying on the infrastructure layer, as we always had, to provide those services up to the application, it's the application's job to actually provide those services so that the infrastructure layer can get simpler, right? One of the things I was really excited about was the Docker announcement where the Swarm stuff landed, where they can do like much easier initial setup of the cluster that allows us to then schedule Docker containers in cool places, and we can use Compose. So like that fits super well with a world where the application handles all of its management and orchestration, right? Because I don't need a complex scheduler, I need a simple scheduler just so I can get stuff running. And ultimately, we're doing it so that our teams can simplify their own behavior, they can empower each other to work better together, and accelerate the way they work, which, if you think about the evolution of automation, this is what we've always been trying to do, right? We've just been getting better at it and better at it in every successive generation. We have a bunch more to do, and it's all open source. The website's open source, Habitat's open source, we're building a package build service, that's gonna be open source, all kinds of stuff. So if you wanna come help, we'd love to have you. And that is my talk.